Hey, welcome back to the shop. So, as you notice, shaved my head. It is getting hotter. We just did graduation and did the walk. I had full head of hair and beard, and it is now July, and it's hitting around 100 degrees. So, yeah, I had to slim down on the whole Jeremiah Johnson thing going. So we are now going into our second of the last term. This part of the class, we are dealing with Drivelines 2. And we are starting the class with doing the angle measurements on a driveline. So working angle, phasing, everything like that. So in doing that, of course, you're going to need a couple of tools. One, you're going to need a digital protractor, the same kind of protractor I used when I showed my alignment video. It's extremely helpful. You'll want probably a socket that will fit on the bearing caps for the U-joints, because when you're doing your measurements, there's not a lot of room to put the protractor, and so you need something that's going to be flat, not wobbly, that'll sit nicely and give you a pretty accurate reading. So we're going to go over a few things now. When we're talking about measuring driveline angles, we're talking about the output from the transmission, so that U-joint, all the way back to the differential, and depending on if you are a tractor trailer or a tractor versus a pickup, how many drivelines do you have, depending on, it will depend on what you have to measure. So the video that I have, we're just measuring a pickup truck. It's just a Duramax, Chevy Duramax. So we only have the 2 tubes to measure instead of the another axle with an inner axle. So when you start, you want to do a visual inspection. So you want to basically look over the entire drive shaft. You're looking for nicks, dings, dents, anything that could affect the drive shaft, because this drive shaft is going to be spinning at a certain amount of RPMs. Any dent or ding will throw off the centrifugal force and cause vibrations. These are the vibrations that you'll feel through the entire vehicle, all the way up into the pedals and the steering. So you want to basically be aware of those things. You want to look for those things. Because that'll basically show major damage. You're looking for the same things that I talk about in pretty much all my videos. You're looking for rust, you're looking for elongated holes, cracks, everything. So this is your visual inspection period to note anything of major importance, because if there is something major, you don't want to proceed further. You want to go ahead and get that fixed, because those things will throw off your readings. Those things will show eventually in your readings, depending on what they are. So when you start, like I said, visual inspection, you're also checking for movement. Eventually you'll also be checking for runout. So what we're going to start with is the first measurement, and that is going to be working angles. Now the working angles are basically, you're starting up at one U-joint. Now the universal joint, of course, will be the U coming off of the shaft, the cylinder, and then the U coming out of the input or connecting to another shaft, and the way they go. So you are going to measure one and then another, and that's the difference. You don't need to measure the other two, you just need to measure the one and then the other, and then from there you'll take your difference. So what you'll do is, once you read the one, you'll rotate the shaft, take the other reading, and when you're taking the reading and you're placing the protractor, you are going to place that protractor parallel, as you see here, you place the protractor parallel with the drive shaft. You want to get it as parallel as possible, as straight as possible. And again, utilizing a socket or something that'll give you a a flat surface to read off of. Again, something I mentioned in my other videos, you're always looking for a fixed point, a solid, flat, fixed point that you can measure off of. So once you take those two readings, depending on the readings, of course, for your protractor, if there's a little arrow on the protractor, so if it's on one reading pointing up and the other reading pointing down, you want to add the two numbers. If both arrows are pointing down or both arrows are pointing up, that's when you'll subtract and take the difference. Now, for the working angle, that measurement has to be within 3 degrees. Sorry, it has to be within 3 degrees. Anything out of 3 degrees, you're having a problem, because basically the angles aren't going to sit right. That's going to be a vibration. You know, and the vibration, of course, is your first sign of something's wrong with, you know, with your vehicle. The next thing you want to measure is phasing. Now, phasing, I don't have it shown here, but phasing is when you're measuring the single part of the drive shaft. So from U-joint to U-joint on the drive shaft, the U-joints that are connected to the drive shaft. Now, a lot of people get that confused, so when they're doing their measurements, you know, they may measure the output of the transmission and then come over and measure, you know, the other connected drive shaft. You're not going to get good numbers from that. You want to measure what's on the drive shaft. And now what phasing is the twist in the drive shaft. Because as a drive shaft rotates, depending on the angles of the input and the output, basically that will cause kind of an acceleration and deceleration all within the revolutions. There are several videos you can look up on the internet. You'll see as they increase the angles to the drive shaft, you'll get this zzz, and it'll rotate. It does that about twice for every rotation, basically because of the connecting points of the U-joints. And in order to fix that, you have to adjust the angles of the input and the output so that they are matching. So if they're, you know, like this, you'll get that zzz, or, you know, any extreme angles, then you'll get that really bad phasing. But this also creates a kind of a torque on your driveline, and so it'll begin to twist. So with phasing, you're taking the protractor, and instead of measuring at parallel, you are measuring at an intersect, and you're measuring on the same driveline. So you'll intersect, you'll place it up there, you'll take your reading, and leaving the protractor facing the same way, you'll go and take the reading on the other side, and then from there you'll get your difference on your for your phasing. And that, if you have a difference of more than 1 degree, then it's out of phase. Because if you realize that phasing can only go from 0 to 90, you want at minimum 1 degree, or at maximum you want at least 1 degree to allow for rolling of the bearings in the U-joint. If you don't have any phasing whatsoever, you can get your bearings will start to carve grooves on the inside, and then it won't wear properly. So you want about a 1 degree difference. So again, like I said, it's just looking down at my notes, you know, measuring the twist in the drive shaft, you're measuring the same U-joint that's connected to the shaft. So if there was a shaft, the two U-joints that are coming off the shaft, and that's what you're measuring to be in phase. Because anything else, you just won't get the right numbers. And make sure that you don't turn the protractor. So if you're measuring one way and you go to the other and you turn the different direction, your numbers are going to be way off. You're going to get a really odd reading. Now, the last measurements you want to get, these are going to be using a dial indicator. You see me use the dial indicator when I was doing the inspection on the actuators for hydraulics. that's pretty much going to be the similar thing that we're going to do here. One of the first readings is run out on your drive shaft. When you're doing that measurement, it's just like the actuator. You're going to measure approximately 6 inches from the end on either end, and you're going to measure in the middle. And that's going to tell you if your drive shaft is bowing. Now, as far as run out, you're allotted approximately, rule of thumb is about 20 thousandths for run out. You want under that, but any more than that, you really got to bow. And of course, if you've done your visual inspection and you see a dent and you still do the measurement, you're going to see how that dent has affected your drive shaft, if at all. So when you measure your run out, you want to jack up the front end. You want to make sure the wheels are chalked, jack up the rear end. You want the wheels chalked to the front end. This will allow you to rotate the tire. You want it in neutral, so as you rotate the tire, it's going to rotate the drive shaft. And what you'll do is, like I have here, you'll rotate that tire. It'll cause that drive shaft to rotate, and you'll watch for the needle movement. Now with this one, you don't have to have the needle zeroed out. You're just going to look for the maximum and the minimum on that needle movement and get your measurement that way. So once you've done that and you've gotten your run out, next we'll be checking the end play. So end play, you're setting up the dial indicator right on the U-joint, right at the bearing cap, and you're just giving a pull. So you want to pull up and down, and then you want to do side to side. Now, end play, you're looking for about 1/1000th to 15 thousandths, so not a lot of play. You don't want that to really move, again, because that's lending to vibrations. That means you're going to wear out bearings, you're going to wear out joints, even eventually go to a broken axle. So you want everything within a tolerable range, kind of a preload range. Anyway, so that is pretty much all the measurements that you have for that. When we go into our next videos, you're going to see an semblance of videos from me, because I am basically taking 2 classes a day, so now I'm also in fabrication. So you're going to see some fabrication videos as well as some Driveline videos. So hang in with me. Thanks for stopping by the shop again, and we'll see you around.